thanks for Crest Creative helping put this together, and welcome to all of you. My name is Ryan Mayfield. I am the founder of Mayfield Renewables, and one of our mission at Mayfield Renewables, one of our big missions, is making solar and energy storage expertise accessible. And so we do a number of things. We do that through engineering consulting. We do that through working with manufacturers. And one of the big things that we do that is near and dear to my heart is education. And so doing educational seminars is something that we do a lot of. We do this webinar series called Ask Mayfield Anything. And so it's just an excuse really for me to be able to talk with really smart people, such as what we have up on the stage. And so that's what we've done here today. We're doing this live AMA for all of you. So appreciate you showing up. So as we get going, talking about the great transformation, I want to introduce our panelists, our folks that are going to be able to help answer all your burning questions. So first we have Bob Bass, professor at Portland State University. And Bob, you run the engineering department, or the electrical engineering, you don't run the department. But tell us a little bit about your role and what you're doing at PSU.
Yeah, glad to. So thank you. Yeah. That works. We'll just have to swap. Okay. Yes, I'm Bob Bass from.
Does this one works?
Don't do that again. Okay. Am I okay? That might be the problem. I was holding the button down.
There you go.
All right, I'm an electrical engineer. So yes, I run the power engineering programs at Portland State University. So those are the education programs, our bachelor's degree program and our master's degree program. And those have a heavy focus on specifically power systems. And then I also run a research program there as well. And the research we do is focus on distributed energy resource management systems, and kind of looking at distributed energy resources from an agnostic perspective. We're not terribly interested in batteries or water heaters or whatever it may be, but water heaters, DER in general, and how you would aggregate those in mass, and I mean by the millions, to provide grid services. So we are basically tasked ourselves with exploring how you can do that while protecting privacy, minimizing information exchange, and doing that in a way that would encourage huge numbers of people to be willing to participate, to lend their assets to aggregators to provide these services with economic benefits for all.
Great, thanks. And then next up we have Shel Willock, the CEO of Iridian. And Iridian provides battery R&D services. Am I saying that correct? Uh-oh.
No, it's not.
Yep. Check.
Okay, and now it's working. Okay, yes. My name is Shel Willock. I'm the CEO of Iridian. Iridian really was founded to help solve some of the supply chain issues in the battery industry, really focused on graphite. So graphite is a material that's used in nearly every commercial battery technology that's on the market currently, and about 95% of graphite is currently produced in China. So we work with graphite producers outside of China, such as graphite mines, biomass companies, carbon capture companies, as well as recycling companies, in order to get their material to a battery grade product, get that product into a cell, and then get data so that they can either show their investors or hopefully secure a contract from an OEM and get it on the market.
Awesome, thank you. And then we have Eric Dresselhuys from ESS, the CEO of ESS. And yeah, love to hear about your
Hey, did it work? Hey, amazing. Yes, thanks, Eric Dresselhuys from ESS. Happy to be here. I've spent the last 30 years or so working in energy technology across a range of different technologies. I've been the CEO of ESS for about, coming up on 3 years here in the spring. ESS, for those of you that don't know, was a Portland founded flow battery company. We make an iron flow battery. We're just down in Wilsonville. So I could have ridden my bike here from our plant. So we have, along with Powin and some other companies, there's a little battery valley starting to happen here in the greater Portland area, which is great from a talent development and kind of economic development perspective. We are focused on that longer duration, so maybe we'll get into that as part of the conversation that came up during Mike's talk.
Great. So we're here to talk about the great transformation following Mike. That was, very helpful information. Actually stole a little bit of my thunder, so thanks, Mike. Appreciate that. So a lot of the same stuff, though, that we're talking about, seeing this huge explosion, electrification, all those kinds of things. So we're going to continue that discussion. As we were getting prepared for this talk, we decided that we were going to, talk about where we were at, where we're now, and kind of where we're going. And it didn't dawn on me till this morning, looking at all of these beautiful Christmas decorations. This is kind of a Christmas Carol theme in the sense of we're looking at the great transformation in years past, the great transformation of years present, and then the transformations yet to come. So with that, I thought that we could, use that as our theme as we're moving along. It's interesting to me, and talking with our panelists here, where we were, grid tie solar. That's when I got my start in the industry, early 2000s. Hard to believe that was 20 years ago. It seems so short yet so long ago, where we were first seeing our first solar systems being put on the grid, and some of the big fears from the utilities at that point were, the solar is going to backfeed to the grid, it's going to hurt the alignment, all those kinds of things. And so to see where we stand today, talking with utilities, they want the inverters there, they want to be having the demand charge, they want to have all those that support. So to kind of open it up to our panel here, just wanting to know with some of the technologies, standards, or projects from the early years, do you see, where the transition that stuck out to you? So Bob, I think lead that with you, and just in terms of, what you saw in the past and kind of where it's, leading us to where we're at now.
Pretend to be a history professor for
A little bit,
Yeah.
yes.
We can go back to and I talked specifically about, or more generally, in terms of distributed energy resources, not batteries or photovoltaics, but it applies to the whole gamut. So we can look back to where distributed grids first started to come back. We're not going to go back to the 1890s when it was distributed, but with distributed energy resources being aggregated for the first time by Detroit Edison and then Florida Power and Light, when they started using direct load control to bring water heaters and air conditioners into aggregation systems for demand response. So that's reaching back quite a bit. And back then there were no standards. We do a lot of work with standards and really emphasize that because of the value you get from interoperability, but it was really ad hoc. So the systems were being put into place on a one-off basis, or it was expensive to go out and make the connection to the water heater and then tie that back into the utility, and then custom built a dispatch system that could then get the aggregation to go into place. And we've seen quite a bit of evolution over time, going from direct load control to systems that are more user-oriented, and hopefully eventually getting into something that's more request response based, like we do with when we order stuff online. And so that's the kind of transition we're starting to see, and trying to get away from the idea that, yes, these assets that are owned by people are under the control of a utility who can press a button and make your water cold at their leisure. So that's the DER perspective on the history.
And so, Eric, I know that you have some history with, smart grids and things like that. So just with, your perspective on kind of that history, some of those projects, some of those technologies that you were seeing that kind of helped lead the way to where we're at now.
Yeah, well, to me, I've always worked on the kind of the technologist side. So, you're in an interesting position for everybody in the room that's interested in energy and the energy transition because of the nature of the market that we serve, right? It's a very heavily regulated market, and it's a market that has, I'd say, evolved over the last 100+ years versus something that was, anybody ever sat down and designed, right? Nobody ever sat down and designed the grid. Nobody ever sat down and designed energy markets. They've just they're kind of living things that kind of evolve over time. And so I think it's important to understand that history, and it's also important then to think about how technologies are progressing over time, whether they're progressing for the energy market or they're progressing outside. And I appreciated Mike's comment earlier that, nobody started to invent lithium-ion batteries thinking, hey, we could go to a grid thing with that, right? It was invented for a totally different reason, but the underlying technologies evolve. And the reason I bring that up is, as I look back, I raised money for my first startup in the energy business in 1996. And you talk about things like climate, is that even a problem? Like, I mean, people talk about clean tech 1.0 in kind of the mid-aughts. And I think I must have been there for 0.1, the beta, and what we saw happening then is that you've got to predict, you can learn lessons from how technologies have evolved in other industries to predict how they will impact the energy business going forward. What's different today than was different at any other period in time is all of that, from at least my experience from the mid-90s till very recently, happened against two dynamics that I don't think can be understated. The first was that almost nobody wanted to put real money into building these technologies. The venture capital market, the early investment market, was very, very limited for clean energy technologies for a really, really long time. That's very different today. And the second thing that's different is that really large, powerful forces were fighting the thing happening, right? It's true that utilities, and it's not true today from my experience, it was true that many utilities really, really, really just didn't want the change to happen. And so it was the convergence of technology evolution and advancements hitting at the same time that we now have regulatory imperative. And I think that's what is different from what we saw before to what we're seeing today.
Yeah, and those, to me, it's interesting. Like, I was listening to some, doing a little research on this, and the financial aspect of this is very just kind of that part of the transformation. That's a big part of it, and being able to, having those avenues are an important part. So as we move into, don't want to spend a whole ton of time on the early stage. I want to talk about, where we're at now, kind of where we're going. But, the policies, they definitely have an impact on that. And the IRA was mentioned earlier. It's definitely going to be something that impacts us moving forward. What we're doing now, the policies in general, things like net metering in general are a really important part of, that great transformation of how we're going to get there. But as Mike was saying, and this was exactly what I was going to try and bring up as well, is this huge increase in demand. I mean, we're seeing electrification of our vehicles. We're seeing electrification on, at our homes. We're transitioning to a lot of, electric-based appliances, things like that, getting away from gas, getting away from burning things. And with that, there's proposals of tripling the amount of renewables that are on globally, tripling the amount of renewables that were being deployed. There's estimates that we tripled from 2012 to this year to last year, that we basically, in 10 to 12 years, we tripled the amount of renewables that were on the grid globally. And we're going to have to triple that again in the next 8 to 10 years if we're going to keep up with this demand. So this is a huge, there's a huge problem, and it goes financial, regulatory, policy, electricians, all of that comes into play here. So one of the things, so with that, kind of the idea being wind and solar are going to dominate that market. I mean, I think there's not any denying that wind and solar are probably going to be 90+% of that mix of getting the renewables onto the grid. And so those being intermittent resources, we can't have the sun up all the time, wind can't blow all the time. We need to have some form of storage. And so that's where I wanted to, kind of bring Shelly, ask you, what are the storage technologies that you're seeing, being what you're doing with the R&D kind of stuff, what are those technologies that we're seeing now, and, kind of looking forward a little bit?
Yeah, so currently we're really just seeing a lot of LFP primarily, lithium batteries on the market, some NMC still, but really those have been phasing out for the most part just due to safety concerns and things. Of course, we do have some other alternative technologies, I would say, like flow batteries, or I've also seen some alternative chemistries like sodium ion that kind of pop up here and there and then kind of disappear for a little while, but primarily LFP. And one of the things that we're encountering nowadays is that really the main driver in what chemistries we're using and what cells are available is the EV market. The EV market is the one that's primarily dictating all of this because there's the most money there. So whatever they're doing, stationary storage applications typically will trail behind and then take whatever cells are then highly manufactured. And one of the things we're seeing just in the EV market is that even those, what we thought were highly available materials, we're encountering shortages. So even things like graphite, just because something is highly available, like a highly available element, graphite or silicon, doesn't mean it's highly available at a battery grade. So there's still a lot of post-processing and things that we need to do to it. And right now, just all of that happens in China, which is leading to issues where people are not able to source cells. China can kind of dictate whatever they want to do as far as your cell supply. You might be able to source cells there at one time, and then your supply changes the next. So that's kind of where we're at right now, in that everyone is really using LFP for the most part. We're trying to do a lot of our innovations in the US more in our enclosures, I've seen, and with our BMS systems, which has been great to enhance safety further from LFP cells, but not too much new as far as chemistries and technologies, at least that we've seen for a little while in the space.
Okay, so with that, Eric, you've mentioned flow batteries and kind of, it's come up a little bit. Would you mind just giving us the elevator pitch on, what flow batteries are for those in the audience that may not, know the difference between a flow battery and the lithium technologies, just because as we mentioned, they are, considered different technologies, really.
Yeah, very different. So we talk about MC versus LFP, and it all kind of looks a little bit the same. There's some different chemistries, but it would, for all the world, you can look at their lithium cells. They look a lot like a AA alkaline battery you popped into your remote control, right? So in all of those battery technologies, from an architectural perspective, you've tethered together energy and power, right? So not to get too into the weeds, but if you want longer duration, and Mike alluded to this, you just put more batteries out, right? And you got the same power output, and you can use some variability on that, but then you're not optimally using that technology. A flow battery works fundamentally differently. In a flow battery, you separate power from energy in the design equation. So you have a cell, so it's a stack, and stack, if you've been around anything in the energy world, you hear the term stack. There's stacks in fuel cells, and there's stacks in desalination equipment, and there's stacks in hydrogen production. So we have a stack, which is really a stack of batteries. You look at it, and it looks like a sandwich from the outside with 100 layers in it. And that's 100 batteries stacked together. But the electrolyte is kept separately in a tank off to the side. And it's called the flow battery because you flow the electrolyte through that battery cell. And what we're doing with our technology, our electrolyte is iron, salt, and water. And I ask you to keep that in mind for a couple of reasons, but one was just mentioned, like, do we have a plentiful earth abundant supply chain? And it's hard to beat iron, salt, and water. And what we do is we flow that electrolyte through the cell, and as we're charging the battery, we're plating the iron in that electrolyte to a surface inside the battery cell. For those of you that are not from the technical side, think of it as making rust. We're literally just plating rust at increasing thicknesses, and the thicker the rust, the longer the duration. And then when we need the power back, we flip the polarity, we de-rust the rust, so the iron goes back into the electrolyte, and we get the electricity back out. So why is that important? The marginal cost of adding more duration is the marginal cost of electrolyte. You don't need more batteries, you don't need more containers, you don't need more systems, you just need more juice. And the price of the juice, for lack of a better term, is kind of sub $30 in today's context per kilowatt hour. So even the most ambitious view of how inexpensive lithium ion will get, nobody has kind of said $30 a kilowatt hour. And so that's the reason you do it. It has some other advantages from the supply chain perspective, from a safety perspective. Now, there are other flow batteries, in full disclosure. There's vanadium flow batteries, there's zinc bromine flow batteries. So there's lots of different chemistries you can use. And there are, as was talked about before, a lot of different technologies to store energy. My view would be that there isn't going to be a single, everything can't win because it never happens in any market. There's not like an infinite number of winning technologies. But in this market, given the size and the scale, I don't think we would also wouldn't predict that there's going to be a single winner because there's just different uses. So, different applications are going to require different things. And I agree with Mike's comment from the earlier session. At this point, I don't know that we want to place, it's kind of like you're in the brainstorming session. You don't want to like just discount any ideas at this point. A lot of them won't make it, right? A lot of the technologies that are being funded will not be able to do it at the scale or the cost. But at this point, we need to explore them.
Great. Thanks for that. So Bob, I wanted to ask you too on, we talk about this mass electrification and how, we're going to everything being electrified. And I know on some of the projects you're working on, interoperability and just kind of how the systems work together. So I guess question for you really is, it's a small question. How does this impact the system overall? But, how all these different systems working together, how do you see that working? And, what are some of the hurdles that you're seeing associated with that?
Right. So we're talking about rebuilding a very distributed system, right? That means putting participants back into the mix, those who are going to contribute to power production and shift their power consumption according to the needs of the market or the whims of the weather. So that in order to get that to happen, you have to have systems that are networked together. In order to get systems that are networked together, you have to have a tremendous amount of interoperability. You have to have the ability to cheaply and quickly connect millions of things to each other. It's a lot easier to, take a power plant that's 200 megawatts and create a connection to your central authority than it is to take 200 million devices and connect them all to your central authority, right? So in order to do that economically, there has to be a very strong emphasis and an intention to make sure that that ability to plug and play is there, and that requires a lot of effort in developing standards, making sure that those standards are adhered to by the folks that agree to participate in the system, and making sure that the implementation of those standards is compliant with the actual information exchange from device to device, and then the device has to be conformant as well. It has to actually respond in a way that's going to be productive for the system. So that all along those chains, you want a system that's going to be able to do that without a lot of intervention. You don't want to have to go into everybody's home and tune their water heater to make sure that it loads up when you tell it to load up, or it sheds when you tell it to shed, because you can't afford to send a plumber or a lineman or electrician into that home when you're only getting 4.5 kilowatts and 500 watt hours from that every time you dispatch it, right? That's pennies. And so that interoperability and compliance and conformance testing is incredibly important to ensure that the costs are as low as possible. And that, I tend to speak from the small scale DER side, but that applies as well to battery systems. You're talking about placing battery systems at every single substation, talking about placing batteries at every single commercial building or every residence. And having these things work together in concert to provide grid services, to do frequency regulation, frequency response, voltage support. They have to tie together in a way that's economical, and they have to be done in a way that gets them to respond in concert in a way that's beneficial to the system, to these grid service dispatches. PNL, Quality Logic, anything else? Those are my interconnect people over there. Interoperability. This is kind of my hounding point, if you will. So, and right, safely, of course. Yes. Can I give you the mic? Is that So the question is, how far do we have to go? And we have quite a ways to go, so.
So, I mean, so that all sounds very daunting to say the least. And so, so I guess my question is, how does that get deployed? So, what are the standards being written? How are they being implemented? Are they, are at the manufacturer level? Are manufacturers doing that? How are we to see this, come to fruition?
Excellent, yes. So a lot of this work is being done through standards bodies, and those include groups of folks that represent the manufacturers, they represent utilities, they represent end users. There's, if you look at the people who are in these bodies, in standards bodies, organizations, they're all the folks that stand to benefit from the interoperability that you're looking at. So a good study to look at would be what's going on in California with inverters. So we've all heard of UL 1741, SA, SB. There's also IEEE 1547, which dictates interconnectivity for inverters. But there's also the requests or the demands from the California Energy Commission that all inverters within the state of California that are installed by utilities, by IOUs, have to be able to speak one of three languages. They have to be able to speak DNP3 for some reason, Sunspec Modbus, or IEEE 2030.5. And that's setting the stage there that all inverters moving forward in the system that get installed are able to communicate using those standards, right? That as folks choose to install these things in their homes, they will in future, or maybe even the near future, have the ability to connect to an aggregator or a utility because their device is already enabled, because it's already sitting there able to speak 2030.5 or Sunspec. So that's going on now. Another example is the requirement that is now codified in both Oregon and Washington, and hopefully soon in California, that all water heaters that are sold in these states have to have ANSI CTA 2045 capability, i.e. they have to have an eco port, and that eco port needs to be there so that that customer who purchases that device has the ability, at least in future, to connect that water heater to a utility program if they so choose. So there are things that are going on, from the consumers, from the inverter side, as well as from the appliance side, and I do expect that to expand to other appliances going forward.
So is that something as manufacturers you are, I mean, I guess, Eric, I'm looking at you directly as a manufacturer, but Shelly, is that something, you're both of you, are you seeing that?
Yeah, and and by the way, I think it's fantastic, right? Because, well, for a couple of reasons. The alternative for somebody like us, we build one thing, right? We build a battery that goes within a system which is controlled by somebody's third-party software that has to communicate over, a communications network of some sort. And if we had to invent all of that or customize all of that for every time we wanted to do an installation, the pain threshold of doing that would be tremendous. So it goes too slow. And I go back to the comment, that you were making, Ryan, before about just the scale of which we need to do things. The first thing is that, we talk about this like there's a central planning authority that's going to coordinate the deployment of all of this stuff, right? And that's what a system looks like, right? It's an IBM mainframe with IBM, terminals that, uses IBM tape in the, in the machine. And that, it's not that, it's an ecosystem, right? Where different people are going to bring different parts to the party, but the whole thing has to kind of work together. And you say, that's really incredible. How would we ever come up with a system like that? It's called the internet. Like, we already invented that. We know how to do that. And we know how to do it really, really quickly. Now, it's a little different in energy. There's some complexity to it. But, is anybody here a PacifiCorp connected customer? Or is everybody Portland General? So go to your house, go look around the back, look at your meter, and it says Silver Spring Networks on it. That was our last company. And that's an IPv6 enabled network that can talk Wi-Fi and Zigbee out the back. And that was designed and deployed in 2002 when nobody had the foggiest idea what any of that was going to be used for. Right? But we kind of knew there was stuff that was going to come that was going to want to get connected over protocols. And so you put some capability in doing it. The marginal cost of having interoperability was really low. The value creation that comes out of it's really high. Now, unfortunately, most places, they haven't used a lot of that capability, but it's not a technical limitation, it's a policy limitation. And so, we kind of, that's back to my earlier point. You gotta bring the technology and the policy together.
Yeah, and none of us are necessarily policy people up here, and there might be some policy folks out there, and it's definitely a big part of it, and it's definitely something that, I can sit here as an engineer and gripe about how, if they would just do it this way, then things would be a lot easier or better, and I'm sure they can say the same thing on the other side, policymakers about engineers. So, two-way street, I'm sure. But so that kind of makes me just think about a little bit. And so, putting in systems that weren't necessarily, what they were intended for, or anything like that. So it's an important just aspect to think about in this whole thing. So moving, looking a little bit, starting to look forward into the, transformation yet to come. I guess I'd love to hear from each of you, just, what are the biggest hurdles that you see, that we have to get over as we're trying to make this transformation? Shelly, you want to start with that?
Yeah, I mean, I think one of the biggest ones is just supply chain. We've already seen issues in supply chain and getting materials that we need in order to enable this transformation. And the big one, again, we see that big number of 3 times generation that we need to have, and we need storage to be able to enable that. And we're already seeing shortages of materials throughout. And in addition to the shortages, it's that we are also not in control of those materials. We're seeing things like policy and bans from China on exports of certain things. We're seeing more restrictions on cells, which make it difficult for us to enable that kind of transformation. So I think really the key to me is in diversifying a little bit and at least being flexible in what we are able to receive, especially since EVs are experiencing a similar growth, which are also going to have a battery demand. And I tend to think EVs are going to win out in terms of stationary storage as far as the ability to get those batteries first. They just have a lot more money, a lot more businesses behind them in order to get those cells. But I think having other kinds of technologies that are built for these kinds of applications, there's not going to be competition for those kinds of materials and those cells. These companies are here for this market. And also just making sure that we are able to be flexible, we're able to build good relationships in order to try to manage the shortages that are to come, because they are coming.
The vehicles comments, I think it's really interesting. So I'm not necessarily EV, can't speak about vehicle to grid and things, those kinds of things. I think it's a very interesting thing though in the comment about EVs are likely going to maybe win out on kind of that. I mean, it makes a lot of sense as a consumer, having a battery that can get me to and from work, but then also can come home and I can plug it in and I can run my house if I want. And so it makes a lot more sense in a sense for a consumer as well.
And that's another place where I think policy has a ways to go. And there's been different things in California. I think, even just using residential storage in terms of, having your utility be able to control that and actually making it worthwhile for the consumer. And there are definitely certain times when I've seen that it doesn't seem worthwhile as a consumer for me, in that it seems like your battery would be essentially double cycling. You're going to have half the life of your battery. And sometimes the compensation doesn't really seem worthwhile for that. The batteries are really expensive, and sometimes it's hard to see that they're going to be any cheaper the next time that you're going to be in the market for one. So I think that there's still some work to be done there, but it does make sense that maybe we would be able to use it for these kinds of dual applications. So hopefully something will come up soon.
Great. How about Bob? You want to biggest hurdles that you're seeing?
Yeah. So in order to get these devices to work and be intelligent and interop with each other, we're going to need a lot of innovation, and specifically from the software industry. We need smart UCMs to sit on water heaters to make decisions, be agents on the behalf of an owner, We need electric vehicles to be able to negotiate their price points and movement of energy. We need DERM systems that are going to be able to intelligently gather these things together and then turn them around and sell them as grid services. But we need software developers to do that. And then they have to build products that go into the utility industry. All right, the software folks want their products, they do Scrum project management. So every 2 weeks, they're coming out with a new version, right? And we're going to try to put these things into the grid with utilities who need to have, 75 minutes on their SAIDI numbers, right? We can't have the downtime. We can't take the risk of putting a new software system every 2 weeks onto the system so we can provide frequency regulation and keep the frequency stable around 60 hertz. We just can't risk that. At least that's the utilities perspective. So how do we go about getting all this innovation from the software side and marry that with a utility industry that is very risk averse? I don't have the answer, but that's a very big challenge that I see before us, is that we have two very different industries that could really help each other, but they come at things from a very different perspective in terms of risk.
Eric? Boy, I think we're out of time to go through my whole list of all the things we have to do, but I was at COP in Dubai. So I was at the kickoff of the Global Renewable Alliance, Triple Up and Double Down. If you haven't seen that, it's a pretty great initiative for tripling renewables by 2030 and doubling energy efficiency. And it was the first major announcement out of COP, and at the rate things are going, it might be the last one too. I don't know. What I think a lot about, I do totally agree with the diversity comment. Isn't graphite one of the things that China is now threatening to say, well, we're not going to export graphite anymore? Because all of these battery plants that are going to get built in the US, which is fantastic, and we should do that, don't work at all, because all of the processing of lithium and most of the graphite all comes from China anyway. So all we're really doing is we're taking one little part of the supply chain and moving it here. And by the way, we should do that if we can, but it doesn't fundamentally solve the problem, right? So I love the comment around diversity of supply chains. This is such a big problem. It's such a big challenge that believe me, ESS is not going to win all the battery business in the world, right? That's not the way this works. I think we can make a meaningful contribution to a part of the solution, but we need more things, more tools in the toolkit to make this happen. And then the second thing, it's great. The Triple Up, Double Down initiative is a great one. We're seeing a bunch of things. There's an initiative I'd encourage you to look at that the Clean Energy Ministerial has organized called Supercharging. They're really clever people there. Supercharging battery deployments. That's a multi-nation effort to change the regulation to encourage faster deployment of energy storage on the grid because of all the reasons we've been talking about. So I think those high-level policy kind of goals are great. We need that to translate into rulemaking. So sorry, it is policy, but if you set the right economic incentives, my sense, because I'm a capitalist and an optimist, is that we're going to we'll solve the problem if the right incentives are in place. So the scale at which we have to do this is daunting. And if you look at any chart of how much fossil generation is going out across the world right now, folks, we're losing. We're massively growing renewables, wind, solar, all of it. It's fantastic. At the same time, we're growing the amount of fossil generation on a global basis that's happening is growing faster than we're adding in a megawatt hours basis. It's faster than we're adding renewables. And that in anybody's book is losing. So we have to pick up the pace.
Well, and policies, we definitely can't get away from policy. And, we see things that are, so my world, very much around solar, energy storage, and we see what's happening down in California. Net metering essentially got abolished, more or less. PUC is now releasing new rules around when you can or cannot sell back to the grid at all. So batteries were going to be the answer, and now maybe they're not the answer anymore. And so, policy is going to, and that kind of policy is going to migrate out of California. We're already seeing talks of it here, Oregon, Idaho, in the Northwest. And so all of those things are definitely going to hamper us if we don't, see that, even with all of this extra deployment. So I guess I'll throw in my 2 cents on kind of I think the big hurdles, and that's, around education and our workforce. And it was, talked about, electricians, needing electricians, getting people to go into the trades. But not just that, it's, getting people who are properly trained. So we have, lots of electricians, we have lots of, people that are out there, but even getting the systems that are installed today installed properly and that are safe and operating for the 25 years they're supposed to operate is, there's some big messes out there. And so getting people properly trained. And so that's, again, one of our missions, but trying to think about that and just in terms of the global scale of, everything that we need to bring to the table. And so that's, one of the huge hurdles that I see out there. Supply chain has been talked about a fair amount. I'm just curious, and we'll open this up to Q&A from the audience here in a minute. But how do we build a better supply chain? And what does that mean? I mean, that's a pretty broad question, and it doesn't have to be product specific. But I'm just curious on how do you see that getting better?
Yeah, I mean, I think that there's three main components really, which is the materials themselves, the cells, and then the battery packs. But starting with materials, we're doing a number of things. There's a lot of interesting, innovative technologies that are out there. And someone mentioned earlier, the impact on mining, and if you have any, of the coal marketers on your LinkedIn that you see every now and again, you've probably seen some of those that talk about the impact of mining for batteries. But essentially, there are more innovative processes for that. We're looking at different ways like using natural graphite versus synthetic graphite, which is much less carbon intensive to produce. We're looking at things like biomass, derived carbons and carbon capture derived carbons, things like that. So there's a number of different ways we're looking to just get these materials to start. Recycling, we hit a huge milestone with Apple being able to use their black mass, which is a recycled material, and being able to use all of their cobalt for their cells, basically out of recycled black mass. So we are making big strides there. And I think that that's going to be essential for securing our supply chain on the materials front, is to keep exploring these alternative ways. And then also there's a number of mines that are opening up with the IRA and different types of money available in Canada, in the US. And it's not great for certain reasons environmentally, but it might be what we have to do in order to enable the transition. As far as cells, really diversifying what we could do there. And then as far as packs, I think we're doing a decent job at that. I think just making sure we're ready for changes to come and what kind of chemistries we might be getting and what kind of cells are available. And then, just creating really robust enclosures and BMSs to deal with those changes.
Eric, do you have any?
I would only add, I think that's all. I agree with everything you said. I also think that you have to look at just totally different ways of doing things, right? So in parallel to getting better, and we should do all of the things to get better and do more recycling and all of that, you got to think outside the box and find just entirely new and different ways to do things. I can guarantee you can build a battery without cobalt. You can build a battery without graphite. There are ways around doing these things. They're not going to solve every problem, but it's like any other thing you look at. If you can mitigate the impact, marginal decreases in the demand will have a really outsized impact on the price. So I think we should just be open to finding different ways to go about it.
Great. Well, I think that kind of gets my question. Or Bob, did you have anything you wanted to add
On supply chain?
on supply chain? Or I didn't think you did. I thought I'd make sure that you were. Just all inclusive here. How about within the audience? And there's got to be some questions. So I saw a hand up here first. So go ahead.
Economic development question. And I have to say, it's so exciting to see companies like yours, Eric, and Cowan, finding STAR for Oregon for. Also, I think we're acknowledging Angela and important seed funds for the investments in your company. Right now, the semiconductor industry, Intel suppliers are the biggest contributors to the state coffers. What has to happen in your minds, maybe my end, or batteries, cluster for Oregon? I used to work with Skidmon in Florida. Maybe from him, but no, but it's so fun to see these companies being incubated and growing. I think Mike said billions of dollars of backlog. You know, you guys think has to happen to make this really on the
So I guess the question is, how do we make the batteries the next Intels? Is that kind of the, how do we get the,
Well, and I think you can learn lessons. Again, I'm, you know, you in school, you couldn't look over at the other person's paper and steal the answers, but in life, you can actually do that. So I think you should look at all these other businesses and say, what did they do and what's the pattern, right? So for me, clusters are valuable, right? Because if you said my first answer to your question would be people. Like we've talked about it up on the stage here, hiring people and people with the technical skills to do the work we do. We do, for people don't, we do everything here. We design and we build the cells and the stacks from the ground up in Wilsonville, Oregon, right? Which, by the way, if you're looking for advice, don't try to do that. It's too freaking hard. But that's what we do, right? So we need everything from the trades and the people on the floor working in the factory to building it to engineers to design to every aspect of the business. And where you locate is as much determined where you can have access to the talent to hire the people as any other thing. So the good news is the more companies we get building batteries of different flavors and types is okay. We'll attract more people. And you know what people really love? They love to say, if I move to Portland, Oregon, I can work in the battery business for the next 25 years. I might work for 3 different companies and I never have to move homes or take my kids out of school. The number one reason, having been in tech in the Silicon Valley for 20 years, that I think Silicon Valley, there's, you know, the money and the funding people talk about, but the fact that you can have an entire career and not move is really valuable to people. And so I think that if we can do that with batteries here, if we can get more companies, and if another company wants to come and build batteries in the Valley, like awesome, bring it on. And that'll just attract more people. So that'd be my number one thing. Lithium forest. Well, I see, but now you're biasing to lithium, and that's not going to work. The supercharged. Yeah.
yeah, go ahead. So that's a great question. So what is it going to take to reduce demand? How are we going to become a more efficient users of electricity? I think that's a great question.
Does he pay the bill? So that's it, right? It is a resource, and if it personal metering, yeah. You know, if electricity is priceless, like we wanted when we had nuclear, right? It was not going to be metered, then we'll leave it on, right? And when it's less valuable, when it's more valuable, we'll turn it off. But there's also, you know, sometimes it's just like not quite, expensive enough to bother. And so we leave it on anyway. And that's where institutions like NEA come into play, where we have folks that actively promote energy efficiency programs with large commercial enterprises, with industry, with utilities. So there are a lot of things going on. It's particularly driven in the Pacific Northwest by NEA. So our energy efficiency has actually gotten very, very high in the Pacific Northwest. It's kind of abnormally high compared to the rest of the nation. But NEA actually does a lot of work with actually exporting their know-how to other regions of the United States. So,
yeah. And I would just add one thing that may be controversial, and you may run me out of the room afterwards, but I actually don't think we want people to use less electricity, right? I think we want to reduce waste, and we want people to use more electricity by a lot. And so if you look at what's happening up in Hillsborough now with the data centers because of the Trans Pacific link, internet link, there are data centers flowing in like crazy, and data centers, as people probably all know, are giant energy hogs, right? But what we really want is we want people to get more value for less carbon, right? And that doesn't mean using less electricity. That means thinking differently about where the electricity comes from, how we store it, how we deliver it, so that people, human beings, get more value out of using electricity. And I think that's a little different than Jimmy Carter, bless him, in the 1970s, saying put a sweater on and turn the heat down and throw on a sweater, right? Everybody remembers, that, well, not everybody, most of the people here are too small, but, right? But that's what we used to think of efficiency as doing without. And I think we have to really change how we think about that. We want to create more value and have less waste.
You had something in the, so virtual power plants are, definitely something that's, I think that's a concept that's out there that's, I think has a lot of weight to it, and there's some really good legs to it. As far as, fuel cells, I'm not sure if anybody here wants to
I
tackle
would
that at
just
all.
say, there's a ton of really cool stuff it's development. The one thing that you're hearing a lot about now is hydrogen fuel cells, because we are in hydrogen mania. If you're not aware that green hydrogen is going to solve all the problems. And so you're hearing a lot about that, and you're seeing a lot of people develop different technologies that can use, or at least theoretically use hydrogen. How we're going to get the hydrogen there is a little unclear. Um, uh, but I think it's a continuum, and I think we're going to, as soon as there's incentives for people to do it, I think the prices are going to drop pretty dramatically.
Yep. Yeah. So the questions around price support and price stabilization. So are there OEMs out there that are working towards kind of, or financial institutions, I guess, more of,
Yeah, so from the clients that we've talked to, or at least the OEMs that we work with, we don't work with too many most of the OEMs we work with are more in the automotive industry or the consumer electronics for the most part. But for the most part, it's a scramble for a lot of them just to get product. So actually just securing contracts to get material in general is not quite as secure as you might hope it would be for a lot of them. So I think that that's one of the reasons why you might be seeing some of these fluctuations. In addition, actually getting secure reads on how much material is actually of the right quality at each of, depending on what material we're talking about, but mining material, for example, we have seen some mines that really aren't delivering on their contracts necessarily to actually deliver that material in time. So we're seeing kind of pretty big price fluctuations kind of across the board. And ultimately, we're seeing kind of a difficult situation with many of our OEMs just on securing contracts in general. So I think that that's probably where that arises.
so I think we have time for maybe one or two, depending on how much more, how in-depth the questions are, so.
Apologize in advance, it's opening a can of worms, but.
Okay, we're gonna stop you right there and we're gonna move on.
Interconnection. So interconnection has been a hot topic. It's one of the kind of four horsemen of the apocalypse when it comes to the energy transition for a while. And I know that there's been some activity in doing things like combined studies to accelerate it, but I've heard some really alarming statistics in the past few months of like on average 5-year wait time to get new projects added to the grid. And since we're talking about energy storage in particular here, different from transmission, different from a large scale solar development projects, are those the same wait times we're seeing currently? How big of a deal do you think that interconnection queues are going to be in the near to long term, given some of the updates that have been made currently? I know, again, policy, but
Yeah.
I'm just kind of curious how big of an issue that actually is.
Yeah, so the question is really, interconnecting these systems with the utility grids. We are seeing, huge wait times. Just the interconnection study alone it can be months, if not years in some cases. And so they think the question is, how big of an impact will that be on this transformation in general? I don't know, Eric, if you've had
Well,
direct.
and the worst part of it is the longer the queues get, the more people that throw in phantom fake projects to try to hold their place in the queue, which makes the queue longer, which makes everybody panic, and it makes me want to sell a bunch of tulip bulbs to people, right? I mean, it just kind of goes the wrong direction. I'd say a couple of things we've seen happen. First off, storage is actually a part of the solve, not a part of the problem. So there's this notion of storage as a grid asset, which is coming into vogue. I know that it's being talked about here in Oregon and in California quite extensively. The problem we have with we don't actually have a transmission problem. Transmission utilization in the United States is at about 30%, right? So it's the same problem you have on I-5. At 2 o'clock in the morning, it's really easy to go up and down I-5. The problem is 5 o'clock at night. It's a congestion problem. It's not a capacity problem. And so if you can levelize over time and you can move electricity around through the grid at more opportune times, we can get a ton of capacity out of the existing grid. But the problem is everybody right now, to the point that's been made a couple of times, wants to go push tons of electricity onto the grid at 2 o'clock in the afternoon when there's an overabundance so that they don't get curtailed. Well, we don't want your solar power then. We want it at 8 o'clock at night, right? So I think there's a couple of ways that you can work through it. I would also say, unrelated to our business, there are a bunch of folks working on some pretty cool technologies to actually increase the throughput and capacity of transmission and grid distribution assets. And there are companies out there dedicated to that idea. It's a super complex problem, but I totally hope they figure it out.
Okay, I think I got one more, NS. Is that Okay, so they hand up back there in first, so.
So to skip 25th, conference on climate change, et cetera, you each had one idea. So you hope someone would speak to what question would they answer, whether it is baseline understanding that maybe not everybody in the sector has, policy thing you hope will develop makers there and hoping might inspire folks. What would be that one thing you hope? And other people might have thoughts too, you can share, but at least be
I thought we agreed on easy questions.
Bob, you want to take that one on first?
Oh, yeah, I'd like to solve this problem about how you bring in rapid innovation into an industry that's not really used to it.
Shelly?
Skip, no. I don't know. I think I would be interested in the problem of, utilize policy questions regarding, utilize how we're going to help consumers, with their batteries and integrating that into the grid. So that kind of, yeah,
Well, I'll throw mine out, first off, I'd say that one thing I tell people that ask about coming into this industry is the slowness and the adoption, some of the technology aversion that you've talked to. I think you just have to recognize that that's the world we live in. I think people that come in and try to innovate new technologies into this industry and pretend like they're gonna blow through all that, do it at their own peril. You'll get crushed. You won't win that fight. So you got to learn how to play within and progress through. It's more of an evolutionary thing. But to me, I guess if the big question that I throw out is I want to know how we're gonna change the balance of profit and risk across the participants in the market. So what we tend to do now is we tend to socialize all of the risk and privatize all of the profit. And then we wonder why the system is in imbalance. And I think if we could work out ways to cut that balance a little easier, then it would make things go a lot faster. And I could give a million examples.
And I guess I'd throw mine out there as, I'm not a policy person, but you threw out policy as one of those things as that can help us here. And so seeing policies that are actually encouraging utilities and having utilities be open to this, pardon me to any utilities in the room, but utilities that are open to the idea of integrating these resources onto the grid. And so, seeing those kinds of policies being enacted, I think that would be my if I could have my one wish granted kind of thing.